So we've allowed our system to circulate for a while now, so if we've moved any air out, we've been able to dislodge it and dissipate it out of our reservoir. I've actually done several more deadheading procedures, so let's see if we've moved any air out of the system and check our water level in the sight glass. Again, it's very important to use a sight glass because you're not able to look down inside a cylinder and determine if you've lowered that level. So a sight glass is a very effective method, especially when you have something like an O-ring that's going to set that sight glass. And you can see here we've moved out probably a good 1/4 of an inch. So we've dislodged some air out of this loop. So what we're going to do is we're going to reset our O-ring here, our indicator, to that level. And we're going to go ahead and we're going to deadhead our system, and we're going to see how much fluid drop we get. Again, in a system like this, we would expect to see no more than about 3/8 of an inch fluid drop. If we get much more than that, that means we still have entrapped air. So let's see how we're doing here. We're going to go ahead and we're going to deadhead this. And this one is getting about, oh golly, maybe 3/16 of an inch drop, something like that. So I would say that we have successfully moved the air out of the system. Now, if you have a system where you're getting a much significant drop in fluid level, that means you have a lot of air. And if you can't seem to move it out by going through a series of deadheading processes, in other words, again, throwing that valve closed, wait until that pressure gauge gets up to that sweet spot, throw that valve open. If you can't move it out, and sometimes that's a vertical bore system where the U-bends were installed with water in them, but the surface piping that was installed to tie in your bore field, that still has air in it. It's difficult to force that air back down through the U-bends, dislodging that water and getting it all flushed out. It can be a bit challenging. So what you'll need to do is use your pump and your municipal water source and do what we call a power flush. We're going to make that a separate video segment, which you'll be able to watch a little bit later. So now that we have successfully moved the air out of our loop, now it's time to go over to our flow controller and reorient our 3-way valves, because we have still to flush out between the flow controller and the coaxial heat exchanger, another very important step. I'm going to leave my pump running. I'm going to come over here keeping pressure on my loop. And I'm going to orient my valve so that now I'm sending all my fluid down through my coaxial heat exchanger, because I have to make sure I've removed all the air out of the piping between the flow controller and the coaxial heat exchanger inside the heat pump. You can hear the bubbles coming back. I'm probably going to need to add some fluid. Do that here with my foot. And we're going to let that circulate for a little bit until we see no more air bubbles coming through that. Again, patience, patience. Don't rush this part. You don't want to have to come back and set all this up, drag it all out, and go through this again. So again, do it right. Do it once. So we've been circulating our fluid through the coaxial heat exchanger of the heat pump and the hose kit for some period of time. We're seeing no air returning. I've applied a number of deadheading procedures, again, getting that sweet spot of pressure, throwing that valve open to move out any air that might still be entrapped in that coaxial heat exchanger. And again, let me repeat myself that it's not a matter of the time you've spent, it's the thoroughness and the techniques that you've applied. So I've gone ahead and I've moved my sight glass indicator down to that fluid level, so it's time to go ahead and do a deadheading and see if we have any air still bound in our heat exchanger or hose kit. And as you can see here, we have probably a 1/16 of an inch or so. So I'm very confident to tell you we don't have any air still in this system. So at this point, it's time to rotate our 3-way valves on our flow controller so that we're able to flush both the loop and the coaxial heat exchanger at the same time. And we're going to apply again those same techniques. We're going to apply some deadheading, and we're going to go ahead and see if there's any more air in that system. Again, showing the patience to verify through every step of this process that we're getting all the air out. Again, critical with a pressurized closed loop system. So I'll take my 3/8 drive ratchet, orient the valves to where we're circulating again through both the loop field and the coaxial heat exchanger. So while we have our flush cart pump applying pressure and flushing fluid through the system, an important part that's frequently missed, guys, is you have to actually bleed the shaft of the Grundfos pump. This back bearing is cooled with liquid, and the failure of burping the air out of that means you're going to shorten the life of the pump, snap the shaft, burn the pump up. So it's very important that you do this step. Simply take a blade screwdriver, again, while there's pressure, fluid pressure on here, loosen it up so you get a little drip, and then just tighten it back up and snug it. Now we've burped the air out of that shaft, we've applied some fluid back to the back part of that bearing. Now you're going to have a pump that's going to give you some good service life. So now we've been circulating the fluid through both the heat pump and the loop field for a while. We see no bubbles, no indications of any air in the system, so we're going to verify that. Again, we've done several deadheading procedures. So we're going to reset our indicator on our sight glass to the water level inside our reservoir. And we're going to go ahead and deadhead this. Look for any drop in fluid level in our sight glass. As you can see here, we've got probably just slightly more than a 1/4 inch, 3/16, something of that nature. So I'm very confident at this point we have in fact removed all the air. So now it's time we can do an integrity test of the system. So what we're going to do, we're going to again deadhead the pump. You can see our pressure gauge here is building up near 50 pounds of pressure. And I'm going to go ahead and I'm going to close off the supply valve. My return is still shut off. Now I can shut the pump off. And I'm going to watch for any tail off of the pressure gauge. If we have an excessive amount of air in there, we're going to see some movement on that needle. It's not unusual to see a little bit of creep on that needle over a few minutes just as things start to settle down. If you have any components on your flush cart that may leak, you may want to reconsider and take this pressure gauge out. Again, it slides through that PT port, and install it over here at the PT port of your heat pump. And then you're going to want to shut the shutoff valves off over at your flow controller. Again, this component is an integrity test to make sure that we don't have any leaks, and certainly we don't have any air left out there. So leave that gauge in there for a while, probably a good 10 or 15 minutes to see how much tail off you get. We want to see no more than about 3 or 4 psi, has been my experience.